In this video, we're going to be solving simultaneous equations using the inverse matrix method. In this example, we're going to solve the system of simultaneous equations 2x plus 3y equals 7 and 4x minus y equals to 9. The first step is to write the system in matrix form, ax equals b. So here, A is the coefficient matrix, which is the numbers multiplying the variables. X is the variable matrix, which contains the variables themselves, and B is our constant matrix, which is the numbers from the right-hand side. To get the coefficient matrix, we have to make sure that we have the same order of the variables in each of the simultaneous equations. So here we have the x's and then the y's in both equations. Once we have consistent variable order, we can then write down the coefficient matrix. So taking the coefficients from the equations, the first row corresponds to the first equation. We have that A is equal to 2, 3, 4, minus 1. The variable matrix contains the variables, which are x and y. B is our constants, 7 and 9. So the second step is to find the inverse of the matrix A. We can use a formula for the 2 by 2 matrix. The first step is to find the determinant. So if A is the matrix A, B, C, D, then the determinant of A is always AD minus BC. So in this case, we have that the determinant of A is 2 times minus 1 minus 3 times 4, which is minus 14. Since the determinant is non-zero, it means that the inverse matrix exists. And the inverse matrix is going to be 1 over minus 14, because it's 1 over the determinant. And then what we need to do is we swap the entries in the diagonal. So we swap the A and the D. So in this case, swapping the 2 and the minus 1. And then the two remaining entries, the 3 and the 4, we change the signs to make them minus 3 and minus 4. So now we have the inverse for A. We can find x, which is our variables x and y, by taking x is equal to the inverse of A multiplied by B. So doing matrix multiplication, x is equal to 1 over minus 14 times minus 1 minus 3 minus 4, 2, multiplied by 7, 9. So doing matrix multiplication, the first entry is minus 1 times 7, plus minus 3 times 9, which is minus 34. And the second entry is minus 4 times 7, plus 2 times 9, which is equal to minus 5. Doing the scalar multiplication with the 1 over minus 14, this is equal to 17 over 7 and 5 over 7. So we said in the matrix X, the first entry is X, and the second entry is Y. Therefore, we can read off the solution that x is equal to 17 over 7 and y is equal to 5 over 7. And we can just do a quick check, putting these back into the original equations to make sure that they're consistent. So the first equation, 2x plus 3y, becomes 2 times 17 over 7 plus 3 times 5 over 7, and this is equal to 7. So the first equation is satisfied. And checking with the second equation, 4x minus y equals 9. This gives us 4 times 17 over 7 minus 5 over 7, and this is equal to 9. So the second equation is satisfied. We've found the solution, x equals 17 over 7 and y equals 5 over 7.